Alright, Cal 1, we're doing applications of differentiation. Of course, we're working optimization problems. Alright, so we're looking for two positive numbers again. And this time we're looking for the sum of the first, and twice the second is 100. Okay, is equal to 100. And their product is going to be a maximum. So we want to go ahead and set this up. So as you can see, this first part here is going to be the primary equation, and then the second part here will be, I'm sorry, our second part will be the primary equation because the product is a maximum. Well, anyway, let's go ahead and get started. Alright, so we want to let our two variables be, and I'm just going to let them be x and y. Okay, so here's our two positive numbers, right? Two positive numbers are x and y. So let's go ahead and set up the primary equation, and we're going to let p be the product of x and y. And remember, we're looking for a maximum, so I'll just shorten it to max there. We want this to become a maximum. Alright, and our secondary equation is it's the sum of the first times I think 2 times the second, if I remember right. Sum of the first twice the second is going to be 100. Alright, so there's our secondary equation. We want to go ahead and solve for either x or y in this problem. Alright, and in this particular case, I think what I'm going to do here is just go ahead and solve for x. So this way you see it done a little differently. Now we're going to take this and substitute it right in for the x up here. So we're going to end up having p is equal to 100 minus 2y. Alright, and then that's multiplied by the y. Okay, so there we go. Now we got everything in terms of one variable on the right hand side, and what we're going to want to do now is take the derivative. But before I actually do that, I'm going to go ahead and distribute this y across. Alright, and now go ahead and take the derivative, so we end up with 100 minus, take the 2 out front, 2 times 2 is 4, y, set it equal to 0, and then solve for y in this problem. So we end up having 4y is equal to 100, and of course y is going to be equal to 25, right? 25 times 4 is 100. So we have found one of our positive numbers, and to find what x is, we're going to go back up into this equation here, and we have 100 minus 2 times 25 is equal to, that will be our x, and this looks like this is going to end up being 50. Alright, so we found our two positive numbers. So hopefully you're keeping up with me here. I know I'm probably kind of working pretty fast. Alright, so here's our two positive numbers. Now what I'm going to do here is I'm going to go ahead and go to a graph. Now remember, this is the equation here that we're graphing out. Okay, this is what we want to graph, just in case we forgot our calculus. We want to set up this primary equation all in terms of one variable, right? That's related, of course, to our constraint, our secondary. Alright, and if we graph this, you'll see that there's a maximum occurring right here. And of course, this is where our y value is located. Well, now hold on. Let's look at this. This axis here is not the y-axis. Okay, the x-axis is really the y-axis. All right, because remember, everything is in terms of y. So let's not get confused on that. But down here, and I've got to go. Actually, you know what? Let me zoom. Man, I've got to really do some zoom. I need to zoom this y-axis. Well, anyway, right in here, you can see, is going to probably end up being right somewhere in here, is y is 25. So pretend this is actually the y-axis here, and this is actually, remember, that's the sum, or the product. I'm sorry, the product. Okay, the x, this axis here represents the product. All right. So there's our 25, and of course, you know, you plugged it in, and we got our x value, so forth. So anyway, I'm going to cut it off there. We're done. We're moving on.